Okay, good afternoon, everyone. Welcome to the 394th Transportation Seminar here at Portland State University. I'm Robert Bertini. I'm a faculty member in Civil and Environmental Engineering. A little bit of logistical a point for students. Many of you are taking the course for credit, and just a reminder that there's a sign-in sheet for you, and then also those of you doing a journal for your course, please email those by next Tuesday at 5 p.m. to the psuseminar@yahoo.com email address and indicate what course you are in, so USP 414 or 514 or CE 414 or 514 in the subject line, and that will help us a lot on Tuesday. Are there any questions about the requirements for the course, final requirements? Okay. No questions? Okay. So today I want to talk about transforming transportation through connectivity, and hopefully we'll have time for questions and discussion. But I also wanted to take this opportunity to quickly review the history of this seminar series. I guess this is the 6th seminar that I've participated in as a speaker since October of 2000. I was actually speaker number 1 for the seminar series in a slightly different room. Maybe it was room 204. No. Second floor, 211, is that right? Something like that. There were very few people there. I think we were using PowerPoint at that time, so we weren't using overhead transparencies. But the seminar series has grown. It was originally inspired by a seminar series at UC Berkeley that Professor Gordon Newell, the late Gordon Newell, started in 1965. And when I was graduating from Berkeley, Professor Newell indicated to me that he thought wherever I went as a faculty member that it would be a good thing to sort of replicate that tradition of that seminar series, with the idea that it brings students and faculty together, number one, but also, as we've seen here over the years, it brings together many transportation practitioners, many of our partners. I see Young Park here from TriMet, so it's a good example of a forum, a forum for discussion of important topics in transportation. Sort of a neutral place for us to debate different relevant topics. And certainly we've been very happy to see the strong involvement of the transportation community. We began streaming this live over the web in October 2002, thanks to the fact that this facility here exists where it's relatively easy. And I should say that we always have staff in the room next door who are basically producing this seminar for web viewing. And so we've got hundreds of these archived on the web, available as podcasts for audio only. And I think it's an important resource that we've built up over the years. I participated in seminars number 49, 86, and 152. Two of those were jointly presented, one with Kristen Tufte and one with Tony Ruffalo. And then in April 2008, we figured out that it was going to be the 200th seminar, so I spoke about travel time estimation using freeway loop detectors at that time. And then you see this big white space, big gap in there, but we couldn't quite time it to do the 400th. Someone else will deliver the 400th in the fall, but anyway, this is the 394th, and a lot of people have worked hard to make this seminar series happen, other colleagues, the staff, but mostly you, the students and participants. But let's shift and talk about transportation connectivity, and I would just give a quick little preface and say that for me, transportation as a field is still very compelling because there are so many challenges, and particularly here in the U.S., I see safety as a critical challenge where we are way behind our other, let's say, developed country partners around the world, in Europe in particular, whose roads are about twice as safe as ours. You could measure it and slice it and dice all the statistics in different ways, but we have about double the number of fatalities that we should. And so some people talk about that, and then people move on with their life. But if you think about the fatalities, 34,000 per year or so, 2.2 million injuries, almost 6 million crashes per year. Some people estimate over $200 billion in total cost due to those crashes, and it is a leading cause of death for that age category of ages 4 to 34. So safety is an area where we need to do better. And as you all know, accessibility and mobility and reliability of the transportation system are becoming increasingly important. And of course, the crashes that happen contribute to those, to the lack of mobility and reliability, because whenever you have a crash and you block a lane, or even if you don't block a lane, you impede the flow of traffic. So these are all related to one another. Transportation is a big part of our personal costs in our households, and finally, in terms of sustainability, I believe as the transportation sector, we're doing a poor job. We are responsible for about 1/3 of this nation's greenhouse gas emissions, about 1/3 of all the energy that our entire country consumes, and most of that is in the petroleum category. So I think we have a responsibility in the transportation sector to reduce that footprint, and also to communicate to the public and to decision makers about all of these impacts that I've been talking about. Very briefly, in the realm of transportation connectivity, a lot of the work at the national level has been done through the Intelligent Transportation Systems program. And just to give a short introduction to that, the history of that program, about 23 years of that program, it started off as a research and development program, trying to figure out, are there technologies that could be deployed in transportation, maybe that could leverage advancements in technologies in other fields, like location through GPS satellites, computing power, sensing, and management strategies that have been systems engineering kinds of management strategies that were deployed in other fields. Could we steal those good ideas in an intelligent way, hopefully, and apply them in the transportation sector to improve safety, to improve mobility, and maybe to make environmental improvements as well? That first phase of the program found that, yes, there are indeed technologies that work, and we can demonstrate that they work, but the trick is, how do we get them deployed? Transportation agencies didn't know how to buy software or buy technology devices. They're good at buying, this is a bit of a cliche, but they're good at buying concrete and steel, but institutions were not set up to acquire through acquisition processes. And I see we have Dave Meyer from computer science here, to hire computer scientists and coders. We just didn't know in transportation how to manage that. So the next phase of the program focused more on how to break down those barriers, how to overcome institutional challenges. And then members of Congress got excited and instituted a lot of congressionally designated projects or earmarks that kind of filled the 5 years of the T21 program. Since Safety-Loo passed in 2005, 2006, the ITS program has been back in the research arena. So the decision was made really not to fund deployments of traditional technologies, but to figure out what are the research needs to figure out what the next level of technological advances in transportation could and should be. And that philosophy, the research, development, and to some degree mainstreaming through education and training and technology transfer has continued through MAP 21, which is basically in the ITS category. It's just a almost exact copy of the language from Safety-Loo. So that's a quick bit of history. And just as many of you know, there are technologies deployed around the country. We have a lot of sensing and surveillance going on. There are CCTV cameras and loop detectors and radar sensors, video sensors, all kinds of detection all over the urban areas, primarily in this country, as well as in some rural applications. We do a pretty good job at providing information. So in ITS, we think about trying to measure how the system's operating in real time so that we can manage it better, but also we can give information to users so that you can make better decisions about your travel needs, and that those two thrusts are equally important. So there are a lot of ways that information is given to the public using dynamic message signs, the web, and so on. Some other areas where technology is pretty mature and pretty well accepted include electronic toll collection. Over-the-road tolling is done electronically in many, many places now. We replaced old-style toll booths with area-wide tolling, and that's basically a proven technology. We meter on-ramps. I think about 3,500 ramps are metered, according to Tom Crystalite here in the U.S. at the moment. I mentioned sensors already. We use automated enforcement a little bit, mostly for tolling. We do some managed lanes with HOV and hot lanes. One area that isn't on this slide that's been really critical is the electronic pre-clearance systems for commercial vehicles that almost every state participates in, one of 3 systems that allow trucks basically to bypass weigh stations because they can be weighed in motion and they can communicate wirelessly with the state and fulfill those enforcement requirements. So that's sort of something that the public is not all that aware of, but has made over 20 plus years a very big improvement on the movement of freight on the highways in this country. Highway Advisory Radio, mostly used now in recreational areas. When you enter a national park, you can tune to 1600 AM and get information. Not necessarily a high-tech thing, but it is still used, and people still rely on it in some places. So there are data collection efforts nationally that go on, and I won't read all these for you, but over the 20 plus years of the program, the federal side has spent about $3 billion on intelligent transportation systems, matched by about $18 billion in 75 of the top metro areas in the U.S. And it's been estimated that the overall transportation technology sector accounts for about a $48 billion industry, and that includes telecommunications and some other things. And a couple of the things that I didn't mention before, most toll collection is done automatically now. Many transit agencies, the vast majority of transit agencies across the country, are using automatic vehicle location to improve their dispatching, and also that can be fed back as better information for the public. Transit smart cards, there are a lot of them in places like New York City and so on, but that industry has been moving a little bit more slowly here in the U.S. So when the program started, I wanted to just show you that this is not actually a picture of my car, but that was the car that I owned in 1990, and it was, so how intelligent was an average vehicle that you could buy 20-some years ago? The only things that I can remember is that it had these weird automatic shoulder belts that when you close the door would sort of retract up the door. It had a single CD player that I was very excited about. There was no ABS or airbags, and the mileage rating was in the 20s there. Something that happened in 1989, where I was located at the time in the San Francisco Bay Area, they were planning and they developed a plan for an ITS system to be deployed around the Bay Area. There was a major earthquake in 1989, and basically California shifted its focus to seismically retrofitting the bridges. And it's kind of interesting that it's taken almost from then until now to actually replace the Bay Bridge that's shown in this photo. And then the Bay Area did, since then, also deploy some of the ITS components that they envisioned back then. Nowadays, so in 2014, how intelligent are the vehicles that are on the market? Certainly the vehicles are safer with ABS and airbags. And some in the auto industry say that vehicles autonomously or independently, individually, are about as safe as they can get in terms of the physics of the vehicle design and the technologies for braking and so on. But if you were to buy a Ford Focus, you could get a number of features, not standard, but you could add on some packages that would include things like adaptive cruise control with forward collision warning. So many of you are probably familiar with cruise control, but what this does is it looks ahead using sensors to detect slowing vehicles ahead of you so that you would get a warning, and then also that the braking would be invoked if you were approaching the cars in front of you due to inattention. Has anyone ridden in a vehicle that has adaptive cruise control and felt that braking feeling invoked? No. A Ford engineer took me on a drive in Dearborn, Michigan a few years ago in a Volvo that was equipped with this. And so he was forcing me to drive uncomfortably close to the cars in front of me. There wasn't much congestion in Dearborn, but he was trying to get me to invoke that in the car. And I'll tell you, it was very uncomfortable because he was trying to get me to intentionally not brake as I was approaching a vehicle at a relatively high speed. And then you feel kind of that control handed over. It feels strange, and it's a bit nerve-wracking, certainly the first time that you do that. But it's something that is available in many vehicles now and is actually potentially a life-saving feature. Cars like the Ford Focus, you can get a blind spot warning system that would pay attention to your lane-changing maneuvers, where maybe you would miss a vehicle in your blind spot and give you a warning either in the mirror or through a vibration in the seat. Many cars now have rear-view cameras. I think lane-keeping systems that sort of look with essentially video sensors and try to find the lane lines, and if you start to move out of the lane, you'll get a little warning. It could be a light. It could, again, be a vibration in your seat on the side that you're departing from the lane. Active park assist, you've probably seen commercials or advertisements about this where you can, many people don't like parallel parking here in the U.S., so cars that can park themselves are popular. I think, as shown in the image at the bottom here, and I read that Toyota is going to be releasing a self-parking car where you actually can get out of the car and have it park for you. The current models, you stay in the car while they park. There are traffic sign recognition features where, for example, if you're approaching a stop sign, the sensors in the car would detect the stop sign shape and would, it's a passive system, so the stop sign isn't talking to you, but the car will detect the stop sign, and then you will be warned, or maybe the brakes would be invoked if you were approaching the sign without stopping. So vehicles have become a lot more intelligent. Also alongside of this is what I would call a data revolution, where we've got a lot more data about the transportation system and about all of society now. And most of you, I see smartphones and tablets and things on the desks. You are knowingly or unknowingly participating in this data revolution because, your device is being pinged and pinging cell towers, and if you're using a mapping or navigation tool, your position is being transmitted to your map provider, and so that your position over time is populating databases. I don't know where these databases are managed, but you are participating in something that's being used to provide information about the network. Like in this map down here, this is a screenshot of a map of Portland that shows a color for many of the streets and freeways around our region. And the green, yellow, red philosophy, it's not an exact science because you look at that and you say, oh, there's some little red spots, but when was the slow or stopped vehicle that signaled that redness? Was that just now? Was that a minute ago, 5 minutes ago? Or maybe on a low volume street, was that yesterday? Or maybe last year, June 6th, 2013. So there isn't that, you're getting a nice colorful map, you're getting some information, but you don't know how reliable it is. So our network is pretty well covered by these sorts of different kinds of surveillance. I show, for those of you who like Bruce Greenshields, this is Professor Greenshields collecting data. These are some guys collecting data with a clipboard. Nowadays, there's a tsunami of data coming in through mobile phones. This is not a map of San Francisco, but it's just a plot of lat longs where Flickr photos were taken. So I mean, there are data flying around all over the place, and the challenge is how do we manage it? This little graphic illustrates that there are multiple data sources. Some data could come from travelers or users of the system, where you actually indicate your intent or your desire. Where are you and where do you want to go, and when do you want to go? Vehicles, of course, are generating data. Some of it is staying within the vehicle. Some of it's being transmitted currently. And the infrastructure, of course, is collecting data from different kinds of sensing. So that's where the sources of data are. In terms of how those data are used, there are many, many, many uses for these kinds of data at different temporal resolutions, for planning, for operations, for historical reasons, and then in real time, which is more what I'm going to talk about next. What can you do with high resolution, highly reliable, non-latent data that are coming from vehicles and from the infrastructure. And where we are now is some vehicles are generating data now, some travelers are. You know, I think about when you type in an origin or you type in a destination in some sort of navigation software, whether it's in your phone or at your desktop, someone gets a hint that you're somewhere and that you want to go somewhere else, right? And I don't know who that someone is, but you know, you're typing that information in. When I use a Google type map, you know, I've saved my home and work locations, you know, and so someone knows these desires that someone doesn't necessarily know when I'm making that trip, although they might be able to figure it out. But in the future, we foresee that almost all vehicles will be equipped and generating some sort of data stream. Infrastructure still will be equipped with sensing capabilities where needed, and that we would know more about what travelers' desires are from an origin-destination perspective. I'll skip this. So there are different ways that could happen. What I'd like to do next is talk a little bit about connected vehicles. And we use the word connectivity generally to mean lots of different things. But in the context of intelligent transportation systems, we mean something kind of specific when we talk about connected vehicles. So these are some little Connected Vehicle 101 attempts to describe what this is all about. This is really the heart of the federally funded ITS research program at the moment. And I've already described what some of the issues are in the transportation field. And so if you envision vehicles that can communicate in a highly reliable way at a high frequency with sort of a super reliable Wi-Fi. So we all have used Wi-Fi. I can remember I was sitting in an airport one time for a couple hours, and in the couple seats over from me was a woman trying to connect to the Wi-Fi system in the airport with her laptop, and she was on the phone with her company's tech support, so this was in an airport, for the whole time, an hour and a half, talking, you know, trying to get hooked up to this Wi-Fi system. You know, so the connected vehicle initiative and connected vehicle concept is not about that kind of Wi-Fi where you would have to stop and call tech support. This kind of Wi-Fi is at a slightly different level, which I'll say more about. And the idea is if vehicles are able to communicate with one another or with the infrastructure, you can do a lot to help prevent crashes, to improve mobility, reliability, and potentially even reduce pollution. So this is the concept. The form of communication is a particular standard, wireless communication standard called dedicated short-range communications. It could involve any kind of vehicle, any component of the infrastructure. You do need power in order to, and you need a little radio chip in order to make this happen. The nice thing is that the Federal Communications Commission has set aside a piece of spectrum at the 5.9 gigahertz level just for this transportation safety communications to happen. Not really being used. So, you know, we all own the communication spectrum as the taxpayers, right? So what is the risk if, you know, the FCC has set aside this band, and if no one is using it, what is the temptation? Yeah, and so it's been a constant fight, you know, to keep that spectrum allocation, and so there's a lot of interest in trying to actually get it used for the purpose for which it was actually set aside. And this is different than some people ask if this is the same as the emergency responders communication band, which I think is 900 megahertz, if I'm not mistaken. But the 5.9 gigahertz is what we're talking about for the DSRC communications. And the idea that, you know, there are these nice graphics that show these, there won't be real yellow circles around vehicles and people in the future, but the idea here is that you have a street or an intersection, and the participants in travel in that intersection, the users of the street, could all essentially be connected. And so whether it's a bus or a car or a truck, motorcycle, bicycle, even pedestrian, this kind of connectivity could be advanced. And, you know, there is a difference. I talked about the Ford Focus that you could buy today. Of course, many more luxury vehicles are very, very well equipped with sensors, video sensors, all kinds of sensors for detecting many of the different hazards. But the cost of those sensors on vehicles is quite high. The cost of those luxury vehicles as well is quite high. It's the reason that this track of research has been pursued is that the cost of equipping a vehicle with a device that could participate in the DSRC system is on the order of hundreds of dollars, let's say $200-ish, maybe a little more, maybe a little less. And in the future, of course, the idea is that that cost would go down. And I don't want to mislead you. To an auto manufacturer, every single penny of added cost to their vehicle is magnified greatly. So, you know, 25 cents, $1 of additional cost to a vehicle for an auto manufacturer is huge. So $100 or $200 is even huger. So I want to provide that perspective for you as well. But the idea here is that all vehicles and all users could participate in this system at a relatively low cost. If we wait for all vehicles to be equipped with super duper sensors, then that's going to take a long time for the cost of those to drop. So connected vehicles can be linked. These are just some images that show the types of alerts or warnings. And some people are worried, well, how many flashing lights and chirps are going to be occurring in the vehicle in the future? So of course we have the potential for visual warnings, for audible warnings, also for haptic warnings, which you usually think of as a vibration. So the best example in my mind is if you're departing from a lane and you get a vibration on this side of you, your reaction would be naturally to go back toward the left. So different kinds of warnings can be provided. The warning system, if it's integrated into a vehicle, could also be sophisticated, and based on increasing levels of driver workload, all the other sorts of distractions or media could be dampened. So if you're listening to music and the vehicle is detecting that your workload is going up, perhaps the sound could be muted. The phone call, if you're on a phone call, wireless, phone call, maybe even that phone call could be dropped with an explanation to the other party and saying, well, Rob is entering a hazardous driving situation. He'll call you back in a few minutes. So that can all be managed. The concern about all the different kinds of alerts and identifying which ones are important. So there's been research to demonstrate how that kind of thing can be done. So from a convenience standpoint, there are lots of, people are very interested in parking, especially in urban areas. If you could be informed or directed automatically to the nearest parking spot, if you could kind of move transit information to the next level of quality, knowing when the next transit vehicle is going to arrive, and maybe even letting them know that you want to board their particular vehicle. So it could allow bus transit, for example, to be much more customer responsive. So sometimes if multiple routes serve one stop, buses will stop when no one wants to board or alight. So that could certainly enhance future transit developments. From a sustainability standpoint, some of you may know a little bit about eco-driving, but you could sort of supercharge eco-driving and be much more intelligent about how you are actually operating your vehicle in the most efficient and sustainable way. So I wanted just to say a little word about DSRC because some people haven't heard of it and some people get confused about it. As I said before, it stands for Dedicated Short-Range Communications. It is a short to medium-range communication service. It's been in use for a long time. This piece of spectrum was authorized back in 1999, and there continue to be challenges to that spectrum allocation. There have been also some potential developments that could interfere, so some forms of communication that could interfere with this piece. One advantage is that this is it's essentially a global standard that allows for industry to compete in a fairly level way around the world. The U.S. has worked with Europe and with Japan. The European spectrum allocation is the same at 5.9. In Japan, it's at 5.8. So essentially, without much adjustment, a product manufacturer, a vehicle manufacturer could develop products that could work on any continent. And the key ingredients that have been key ingredients for ITS all along are standardization and interoperability. And so the federal government certainly has been encouraging those two things and playing an active role in that kind of work. There are other people get confused about DSRC, and there have been, the pendulum has swung back and forth. So some people will say, well, why do you need DSRC? Can't you just use regular wireless communication, Wi-Fi? Can't you use cellular communications? And the best way to answer that is yes. So all of these communication forms are complementary for the transportation system. However, DSRC is what is needed for safety-critical communication. So if you can imagine, you know, two vehicles heading towards one another at 60 miles per hour, DSRC gives you robust communications without drops 10 times per second. And in that kind of a situation, think back to your elementary school math problems. You know, if one train left Chicago, you know, when vehicles are heading towards one another and you need to make a very small change in the trajectory of those vehicles to avoid a crash, a robust communication between those, and low latency means low time lag between the messages. So I don't know about you, but sometimes, you know, I get a voicemail that shows up on my phone the day after the call came. Sometimes an email will trickle in and something's odd and it just got lost somewhere. So in this safety critical kind of setting, DSRC is what is needed for the safety critical pieces. But in the future and even now, cellular communications can complement these systems as well as other forms of wireless Wi-Fi, more consumer-type Wi-Fi. The range for DSRC is about 1,000 meters, and as it says here, the data transfer rates are high and the latency is minimal. And you know, with a connected vehicle, connected infrastructure, connected transportation system, it's not only the safety messages that will be needed, because there will be things like signing on to the system, making sure that you are a secure participant and not a rogue participant in the system. And so those different layers, the convenience components, you know, and even the sustainability components could be handled on kind of different channels of wireless communication at the right time. And so you could, you know, there could be communication hotspots, you know, for wireless communication between the infrastructure and you. This is just a graph to explain DSRC that shows on the y-axis latency and on the x-axis the different technologies that exist. So DSRC is way down here, extremely low latency, and the other forms of wireless communication that many people are aware of fall up here on this scale. So when the research for connected vehicles, connected transportation began, some people they developed a tagline called IntelliDrive. There have been other taglines called Intelligent Vehicle Initiative. There have been IVI. There was VII, Vehicle Infrastructure Integration. So if you look around, you'll see mentions of those three different kind of confusing taglines. And then at some point, we started calling it connected vehicles. And that even is a little bit short-sighted, because it's really about connecting the users of those vehicles, who are the people, and it's more than just vehicles. So this is sort of my little graphic that shows, yes, it's infrastructure like traffic signals and roadside devices and cars, but it's also fleets. It's taxis, it's commercial vehicles, it's transit fleets, it's vehicles on port properties, it's vehicles in industrial settings, in agriculture, in mines, in off-road applications where this can also be beneficial. And it's not just the vehicle, as shown on this slide, it's the drivers and the operators of those vehicles who are active participants in the system. And also, all these drivers and operators are carrying their own wireless devices, just like airplane pilots are bringing GPS and iPads into the cockpit. You know, users of transportation, all transportation modes, are carrying with them certain degrees of connectivity and certain types of applications that they're using. And also, it's important that I mentioned ports, but places where different transportation modes come together, like maritime and ground transportation come together at ports. It's an important place for connectivity to be helpful. Railroad grade crossings are also places where two modes of transportation cross. In the railroad industry, they're developing positive train control, which is kind of like GPS for trains, so that you actually know exactly where the train is and what it's doing, as opposed to knowing when it passed some fixed point within some minutes or hours in the past, within some block. And then, of course, the infrastructure on the lower right. So all of these pieces, we envision them needing to be connected so that they can work together better. So I'd like to talk a little bit about some of the safety-related applications. Over the last couple of years, there was a safety pilot done in Michigan. It was a competitive program where several teams competed to house the safety pilot in their location. This one happened to be done in Dearborn, Michigan. And they basically wanted to inform a decision. So a decision process was teed up for the National Highway Traffic Safety Administration, NHTSA. NHTSA regulates light vehicles, among other things. And the idea was to determine whether requiring DSRC devices in all new vehicles would be beneficial. So NHTSA has a regulatory role. The regulatory process includes robust cost-benefit analysis that has to be approved by the White House, the Office of Management and Budget. So the safety pilot was launched in order to generate data so that this regulatory process could begin. And it was always talked about as the 2013 NHTSA decision. To shortcut to the result, the decision was announced. It was announced in 2014, but NHTSA is moving forward with regulation to require DSRC devices in new vehicles. And most automakers have said that they're going to start including them anyway. But the safety pilot demonstrated 6 vehicle-to-vehicle applications. Just the idea has been that the vehicle-to-vehicle communications could prevent or reduce about 80% of all crashes that occur with unimpaired drivers. So that is about 50% of all crashes are of these 6 types. So rear-end crashes, lane departure crashes, intersections, lane changes, opposite direction, and back-over crashes. So if all vehicles had this V2V, vehicle-to-vehicle system, theoretically, about 50% of all crashes could be prevented. And so that's the benefit side of the benefit-cost equation. And the cost side, of course, is the cost to the users, the cost in developing the system, and so on. But these are little snapshots of those 6 main applications. A little image on the right-hand side shows that there is a standard safety message that's been globally developed. And there are, about 10 parameters that are required in order to basically handle or to do these applications. So vehicles can communicate their position, their speed, their heading, acceleration, and a few other things. That is all that is needed to fuel an application that would warn or alleviate these kinds of crashes. And as I said, the safety pilot is now complete. They're still collecting data, but the real data collection has been complete. They had about 3,000 vehicles operating on the roadway network in Dearborn. In addition to those vehicle-to-vehicle applications, they demonstrated 4 vehicle-to-infrastructure applications, one involving signal timing, so that the signals are responsive to the actual positions of the vehicle, so there's a communication between the vehicles and the signals is two-way. Right now, we typically will detect the presence of vehicles and hope that we're really detecting a real vehicle that's going to arrive at the signal sometime later. But in this system, the information is two-way, so drivers could be given information about acceleration or deceleration for an upcoming traffic signal. Curve speed warning is another one. Railroad crossing warnings and pedestrian detection were the projects that were demonstrated in Michigan. And as I said, this has informed the NHTSA decision that was announced a few months ago. This is kind of a list of the vehicles that were included in the system. Most of the vehicles were equipped with relatively small safety communication devices, several 2,200 light vehicles in that category. 64 vehicles were actually equipped in a fully integrated way. So if you had one of those vehicles, it would look like this connected vehicle system had been installed in the factory. So there was nothing bolted to your dashboard, no wires were cut. It was installed in a completely seamless way. There were several hundred what they called aftermarket safety devices that were installed, where you had to take your car to a shop and involving soldering and things like that to install the system. But so 3 tiers of devices were tested: the integrated, the aftermarket, and the basic kind of plug-in awareness devices. And this is kind of a schematic that shows what those different devices looked like. So in some cases, you were at the lowest cost, the vehicle awareness device. You were participating in the system by communicating your position, but you weren't receiving warnings or your car wasn't braking for you at the low-cost end of the spectrum. In the middle, the aftermarket devices did provide safety warnings, so there were some dashboard kinds of visual and audible devices as shown in that image. And then the integrated devices, like I said, it kind of looked like the vehicle had a navigation system built into the dashboard, and all the applications were running within that environment. So just a little bit about stepping aside from safety. The Federal Highway Administration is taking the lead now on the next phase of this work, and I should say that there is a 2014 NHTSA decision coming up for commercial vehicles. So NHTSA also regulates, along with the Federal Motor Carrier Safety Administration, the trucking industry, commercial vehicle industry. And so NHTSA intends to make a decision later this year about requiring DSRC devices in new commercial vehicles. One advantage there is that truck cab data are already standardized and already regulated by the federal government. So whereas individual automobiles, every car company has its own proprietary data network protocols. But in the commercial space, the fleet space, as I would refer to it, I think it would be a lot easier because the data are already standardized, and so it's not as much of a jump in terms of cost for the manufacturers or the owners of those vehicles. In 2015, the Federal Highway Administration intends to release specific guidance for how transportation agencies who would like to build and install and implement the infrastructure side of this, mostly aimed toward mobility, what they call mobility applications, and I'll mention those briefly in a second. But it's very important because the federal government doesn't operate signalized intersections, doesn't operate highways or roadways or transit systems. It's thousands of local agencies, regional agencies, and state agencies who all need to figure out how to participate in this and how to pay for these implementations. So the idea on the mobility side is you would have vehicles and infrastructure generating data, and that hopefully there would be some clearinghouse for that, vaguely referred to here as a data environment. It's not clear yet exactly who would play that role. But through a lot of work with stakeholders, about 6 different categories of applications have been developed focused on the mobility side, the traffic management side. The blue one, the blue hexagon there, is enhancing traveler information systems. The purple one is enhancing emergency response and evacuation kinds of applications. Intelligent traffic signal systems. There's a freight information set of applications, transit operations, and then intelligent network optimization for city kinds of applications. So those are moving forward in a way in the sense that the US DOT intends to fund some regional pilots, so they already funded the safety pilot, and they intend to fund a set of regional pilots aimed toward demonstrating, and not only demonstrating, but implementing some applications within these categories. And that's an ongoing process, and next year, the FHWA plans to essentially advertise a call for proposals for those kinds of applications. I think that there's finally, there's an environmental component called ERIS, where there are 4 categories of applications also moving forward. It's a smaller program, but also under the FHWA, there are plans for regional pilots aimed at arterial, so developing green or eco-arterial management, freeway management, corridor management, and regional management efforts aimed specifically at reducing emissions and reducing energy consumption. So data is a big part of this. So the idea, I have to put in a plug for archiving data, and colleagues here have participated in demonstrating the value of archiving transportation data through Portal. There are 6 test beds across the country that have qualified to be called test beds by the US DOT. What I've said a number of times is there's, to me, not a big difference between saying you have a test bed and having one, but there's an important missing ingredient that, you know, devices and users and systems have to be connected. And so, for example, the system in Maricopa County has been developed by the University of Arizona, and where they've worked with emergency response agencies using DSRC devices to provide signal priority. And so I think I've always thought that Portland and Oregon in particular could be a ripe location for a test bed, and perhaps taking advantage of the emphasis that our state has on electric vehicles, there could be an exciting possible additional dot added to the map for this area. Maybe I'll turn things over to questions, but I haven't talked about autonomous vehicles yet. I did add a few slides here, but the idea is, you know, we have all heard a lot about autonomous vehicles, which is kind of in the news, and the idea is that certainly connected vehicles and autonomous vehicles could be complementary. Fully autonomous vehicles just don't rely at all on receiving communications from any other vehicle or from the infrastructure, so they are sensor heavy. And you know, you see the pictures of the Google cars, or maybe you've seen some around. The LiDAR devices that are on the top are, you know, multiple hundreds of thousands of dollar devices. And of course, those costs will go down. But the idea, at least a preliminary idea, is if the system were set up to all work together, that these could be complementary participants in the network. So just to close, a lot of you know, you could go on forever looking at announcements by manufacturers about what they're going to do in the future. You know, most auto companies have now announced that they're going to be doing something with connected vehicles, with DSRC, with autonomous vehicles. So it will be up to you, students, as the future leaders in transportation, to guide and navigate and figure out how to make all these systems work. There are lots of policy issues that we need to sort of put together that are unresolved. So you, as people working in the transportation field, can play a role in sorting out some of these issues: privacy, security, how are you going to pay for it? You know, are we as a country ready for some of this in terms of willingness to participate in a system where we give away some of our data, where we are, what we're doing, where we're going, in order to become safer or to improve efficiency? Lastly, I think the perspectives on this seminar series, I guess it was always a dream of mine that our graduate students would take over the operation of this seminar. The one at Berkeley is totally organized by students. We haven't achieved that vision. We also, at Berkeley, they have a cookie hour beforehand, and I think have never really done social food, coffee-oriented thing before. We've had a few debates here with a point-counterpoint theme. Certainly, in 1 hour, it's a little hard to do that, but we could do more of that point-counterpoint in the future. And of course, for any of you participating, we're open to your ideas, to suggesting possible speakers, possible topics. And with that, I'd be happy to answer any questions.
What happens with these connected systems when they get hacked? Is that going to be a problem? Are we going to have like false positives and all of a sudden everybody on the freeway slams on the brakes?
Well, it's certainly a key ingredient, and I didn't talk much about the security layer, but there is definitely a security layer that's not my area of expertise, but I'm told that that has been a big part of what they were testing in Michigan, that you would need to demonstrate legitimacy to sign on as a user of the system. So clearly that's an important topic now for all the data systems and even for the vehicle systems that are out there. But clearly that's one of those puzzle pieces that needs to be not only technically resolved, but communicated so that the public are comfortable. Because if you're in a sense trusting that, if I'm trusting that Dave's vehicle is going to be telling me the truth about where it's headed and what it's doing so that it doesn't hit mine, I mean, that is a fairly sophisticated amount of trust that as a user you're having in the system. So it's an extremely important point.
Can you say just a little bit about eco lanes? I haven't heard of those before.
Oh, well, an eco lane, I mean, there are different concepts where, you know, if you're a clean vehicle, maybe you're given priority, or maybe you're, you know, maybe during certain times or on certain days or permanently, you know, not, let's say, vehicles producing emissions are prohibited from using a lane or access to a central city or something like that.
What would it take to make Portland test-ready? Who's in charge of that decision?
It's a good question. It probably wouldn't take that much. I mean, it would take public agencies making some commitments. It would take a little bit of money to go buy some DSRC devices, stick them in some buses or some city maintenance vehicles, some trucks, some personal vehicles, put some DSRC devices in some signal cabinets, develop a research plan, a research proposal, get the partners on board. You know, if these other places can do it, why couldn't we? So it wouldn't take that much, but I think a team is necessary. You know, a team commitment is the key, and a little bit of funding.
Could you announce the name?
My first name, Felicia. Last name, Holloway. Just kind of in regards to developing it, and you were saying the autonomous vehicles are in the news right now. Seeing how they might be complementary, is there anything to suggest that if you're going to develop the connectivity, you might also want to see how to mesh those two? Because ultimately, I think it's like a step, the next step already.
So at the national level, they are beginning. So in the 90s, the federal government funded a lot of research in autonomous vehicles. Then DARPA, the Defense Research Program, had these challenges, these autonomous vehicle challenges, urban and desert challenges. And now private companies like Google are developing this, and universities also. But it's been something that's been developed over several decades. So the US DOT is launching a program to look at the combination of the connected and autonomous. I think, you know, as far as I know, the manufacturers who are wanting to build the autonomous vehicles, they need and want to develop vehicles that will operate totally independently of other vehicles or the infrastructure or the government. So it's a bit, you know, things are moving forward a bit, you know, moving forward and then grabbing results of research that was done in the past. So at some point, they need to converge. Exactly how they converge is not known at the moment, but it's an ongoing topic of research. And in fact, in July, there's a meeting down in California kind of bringing together the autonomous and connected vehicle community. So that's something that's happening. This is the third year that they're doing that. So it's in progress. I'll come back for the 600th seminar and give an update on that.
Marisa. Car.
Marisa, yeah, exactly.
Remember a few, I think about her ITS work in rural Wyoming. And her focus seemed to be about the weather, correct? So how would this, it's DSRC, is that right?
Sure.
How would it sort of play a role in that?
Sure. Well, to me, one of the most exciting ways is that every vehicle could be a weather sensor. You know, the vehicles could be detecting pavement temperature. You would know whether the windshield wipers were on. You might have other sorts of sensors in the vehicle that are already there. Some cars have automatic windshield wipers that are detecting moisture. So if every single, you know, if you could crowdsource the weather data in any given moment, you would know in real time what was really happening weather-wise. If you're the road owner, if you're the DOT, and you want to know where the ice is or where the flood is or even where the pothole is, you could detect this from these mobile probes. You could maybe on your, you know, in a more near-term stage, all state vehicles, you know, we have fleets of government-owned vehicles that could be equipped with these communication devices that would give you a crowdsourced picture of what the weather situation is, because as we all know, weather forecasts are not that reliable, and they're also not very microscopic. So what you're interested in as a driver or as a traveler or as a road owner, road manager is, you know, the details. So that's a very exciting area for weather. I think, Matt, you had
So there's obviously a lot of like benefits to making more autonomous and connected vehicles. Is there any like major downsides that people have been talking about?
Yeah, I mean, the disbenefits, some of those puzzle pieces that I showed, I think people are concerned about the cost. People are concerned about how would we actually do this? Could we get every state and every city and every county and every transit agency to find the funds and then to deploy everything so that they could all work together and that the system could work? Who's going to be that data clearinghouse? You know, I don't think it's going to be the federal government. Are people willing to give away, you know, in a safety critical situation, you need to be willing to give up pretty much every piece of information about you, where you are and who you are. Are you a non-rogue participant in the system? So I think there are lots of what I would call barriers and remaining questions and concerns that might not actually in the end be disbenefits, but certainly are currently unresolved issues. But I think the whole idea is at a low cost, you could have a huge impact on safety, and in a cost-benefit equation, you could save money.
This would seem to mean that all our roads have to be exactly the same mark. How far have we come on that project?
Well, I mean, this really would mean that it wouldn't matter so much how the roads were marked, because you wouldn't be relying on cameras trying to detect signs, but you would have a device on the side of the road every once in a while that would have to be the same, and that would have to be plugged in.
And that's true for lanes?
Well, so yes, so it's not so much about the marking, but it's about the communication system that would have to be integrated. And you know, there aren't that many examples where we're doing something like that now, at least that I can think of. I mean, we've got national networks of things like wireless communications, credit card networks. You know, there are national networks in some areas, but in a lot of areas where it seems obvious that we should have national networks, we don't. You know, you can't. I keep thinking about transit examples, but you can't take a transit pass from Washington, D.C. and use it in New York City or Portland. So there's a lot of institutional work to be done.
I was wondering, like with the DSRC technology, if there's any idea to be able to connect the cars to bicyclists?
Yes, so
warn one of them?
Yes, so I mean, there's been a little bit of testing of that in the Michigan test bed. I think they tested one bicycle and one motorcycle. I haven't been able to get any data on that. But certainly, as a participant in the system, to me on a bicycle or motorcycle, it wouldn't be that difficult. But for pedestrians, that's sort of the larger question of how could you or would you take advantage of the benefits that a pedestrian could have by being detected. Good question.
So I read recently that there are some people that are doing research around having umbrellas that can detect rainfall, so actually have pedestrians contributing to weather data collection.
Right. You know, if we were in a place where people used umbrellas, that's exactly right.
So that'd be a good test spot for that.
But maybe your glasses, a lot of people wear glasses are a commonly worn thing, or, who knows what the possibilities.
That's just what I was going to ask, actually, is what research is being done around the connectivity between pedestrian activity and possibly public transit? Or
Yeah, so the Federal Highway Administration has one small project that's kind of like a literature review that's underway right now. So that the short answer is not that much, but hopefully more in the future.
We are out of time.
Okay.
Thank you, Dr. Bertini.
Thank you, everyone. Thank you a lot.